my dear friends, welcome to class 9 and I am Soham Jagat here with you with chapter number 11, that is work and energy. In last lecture we have seen definition of work, formula of work, what is work according to physics or say science. In last lecture we discussed that we said work done when we have force apply on object, and second most important thing is object should displaced. So we have force and displacement. By the definition of work we conclude formula of work done, W is equal to F into S, that is force into displacement. From the formula we derive SI unit of work as Newton into meter, because SI unit of force is Newton and SI unit of distance or displacement is meter. So we have Newton meter as SI unit of work. But we discussed after name of joule, we said 1 Newton meter is equal to 1 joule. So SI unit of work is joule and that is equal to 1 Newton meter. So we note that 1 joule is 1 Newton meter and that is a work done on the object when the force of 1 Newton displaced by 1 meter along the line of action. We seen line of action of force. What is line of action of force? In this example, you can see figure number 11.4, girl trying to pull the toy car towards her. So in figure, the direction of thread is direction of force and that is the action of force or say line of action of force. After that, we discussed what is positive work and what is negative work. In that, we discussed that if displacement of object is in the direction of force, we call it as positive work, which means if force apply is in this direction or say forward direction and the displacement of object is also in forward direction, we say it as positive work, which means if direction of force and displacement are same, work will be positive. Opposite to that, if direction of force is say right side and displacement of object say left side, which means here angle between force and displacement is 180 or they both are in opposite direction. So we can take work W is equal to F into S. We can take F as minus or we can take S displacement as minus as right here. So in that case we consider work done is negative. We see in one example in which case we have one positive work and one negative work. I hope you can remember the example of bottle. If I lift the bottle in upward direction, force applied by me on the bottle is in upward direction. At that time, displacements of bottle is also in upward direction. So for work, I consider my force, my muscular force, that work done will be positive. But if I consider self weight of bottle, that is W, that is due to gravitational force. This gravitational force, we know that always acting downward. So displacement of bottle is in upward direction and gravitational force in downward direction, or say weight of that object is in downward direction. So here in this case, work done by gravitational force will be negative. So we have positive work done and negative work done. After that, we have our second portion of chapter, that is energy. In that topic, we started that and said that life is impossible without energy, and demand of energy is increasing day by day. As we discussed, our lifestyle is increasing, so the demand of energy is increasing. In this chapter only, we discussed there is a many forms of energy, say light energy, chemical energy, mechanical energy, nuclear energy, and other many kind of energy. Due to our lifestyle and development in technology, we require lots and lots of energy nowadays. For example, think about 50 years ago. There is not much equipment, or say electronic equipments around us that is we have today. So at that time, we have not that much large amount of consumption of electric power, or say electric energy. Electricity is also form of energy that is must needed in our daily life today. So as we have more electronic equipment with us, more machinery with us, more automation is with us, we require more electrical energy. So we can say that demand of energy is increasing day by day. We have lots of vehicle. This vehicle uses petrol, diesel, natural gas, CNG, LPG. This is nothing but the form of energy, and it has energy that is chemical energy, and we convert this chemical energy to mechanical energy by our engines. So we have discussed the demand of energy is increasing day by day. Sun is the biggest natural source of energy. Why? Because we are dependent on plants, trees, and trees and plants need sun for their food preparation. We know that they prepare food by photosynthesis process. Without photosynthesis process, trees and plants cannot make their own food, and without trees and plants we cannot live. So the sun is the biggest energy source for us. After that, we have another option for energy, such as interior of earth, tide, nuclear energy, etc. Let's move ahead. The word energy is very often used in our everyday life, but in science, we give it definite and precise meaning. Let's consider the following example. In our everyday life, we use word energy very frequently. but we have very precise meaning in science for energy. We have one example. When a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. Similarly, an object when raised to certain height and gets the capability to do work. When a cricket ball hits the wickets, stumps, what will happen? It transfer its energy and wickets throw away. Similarly, if we take one object and take it to certain height, it can it has capability to do work. How we can say that it has capability to do work? If we take one stone and raise by our hand, raise by our head and release the stone, what will happen? We will hurt. We will hurt. So there should be some energy by that it apply force on our head. So we can say that the stone which is at certain height has a capability to do work. You must have seen when raised hammer fall on the nail placed on the piece of wood, it drives the nail into wood. What will we do? We hit the nail with the help of hammer. At that time, moving hammer or the movement of hammer push the nail in wood. It drives the nail into wood. We have also observed children winding a toy. We have toys, that is with key. We wind the toys, and when toy is placed on the floor, it started moving because it has spring. It has spring in that toys. And when we wind up, it gets energy. And when we take this toy on the floor, this energy starts releasing. When a balloon is filled with the air and we press it, we notice a change in its shape. If we inflaten balloon and we press it with our hand, we can feel change in its shape. As long as we press it gently, it can come back to original shape. It has certain limit by which if we press it, it can take its shape by its own. But if we further push it, further apply more force, what will happen? It will blast. As long as we press it gently, it can come back to its original position and shape when force is withdrawn. However, if we press the balloon hard, it can even explode, producing blasting sound. We have blasting sound like boom. So it has this sound is also energy. In all this example, the object acquire through different means the capability of doing work. In all this above example, objects are being capable to do work. An object having a capability to do work is said to possess energy. We have to mark it. An object having a capability to do work, it said to possess energy. At this time, I can speak, I can play, I can do some work because I have energy. So when I said I can say I have energy, if I have a capability to do work, at that time I can say I possess energy. The object which does the work loses the energy and the object on which work is done gains energy. Again, The object which does the work loses the energy, and the object on which the work is done gains the energy. Let's take one of the above example. Let's take the example of toy. Spring toy. When we winding this toy, what will happen? We loses our energy. We have to take effort. We have to apply our muscular force. So it means that we apply force on toy. At that time, we loses our energy. But at same time, this toy gets energy. At same time, toy gets energy. Now what will happen? We place this toy on the floor. What will happen? This toy starts running. At that time, running is an activity. That is a work done by this toy. At that time, toy loses energy because it is doing work now. So it loses energy. So we are the object, and by us, we work done on toy. We work done on toy by applying our muscular force. At that time, we loses energy and toy gets energy. Another example we have of balloon. When we press balloon, when we press balloon, we apply force, we apply our muscular force. At that time, we loses our energy, and at the same time, balloon gets the energy, and by getting this energy, it may have change in its shape or it may have blast. So I hope you understood what is the energy loses and what is the energy gain. How does an object with energy do work? As we said that if object has a energy, it can do work. So we have a question, how does an object with energy do work? An object that possesses energy can exert a force on another object. An object that possesses energy can exert force on another object. How? When we press balloon, we can experience certain force on our hand also. That is by third rule, third law of motion. When we press the balloon, we can exert, we exert force on balloon, and at same time we can feel pressure, we can feel force on our hand also. So it exert force on another object also. When this happens, energy is transferred from the former to the latter. And when it happens, energy transfer from one object to another object. This second object may move as it receive energy and therefore do some work. And this second object, if we do work on some object, it gets energy and therefore it do work. Thus, the first object had a capability to do work. This implies that any object that possesses energy can do work. I do work on balloon because I have energy. Now this balloon gets energy from me. So it can blast, it can change its shape. So now the balloon can do work because it has energy. So in that way, we transfer energy from one object to another object. And by this energy, we can do work. The energy possessed by object is thus measured in terms of its capacity of doing work. Important sentence. Note it. Energy possessed by an object is measured in terms of its capacity of doing work. So energy is nothing but capacity of doing work, and the unit of energy is therefore same as that of work. The unit of energy is the same as that of work. And what is the SI unit of work? As we discussed in the starting of lecture, SI unit of work is joule. Therefore, SI unit of energy is also joule. We denote joule in capital J letter. A joule, 1 joule is energy required for to do 1 joule work. 1 joule is the energy required to do 1 joule work, because energy is nothing but the capability of doing work. Joule is somewhat smaller unit. So in our daily life, we use larger unit of joule, that is kilojoule. And we know that kilo is 1000. So 1 kilojoule is equal to 1000 joule. 1 kilojoule is equal to 1000. SI unit of joule and work is same. SI unit of work and energy is same, that is joule. Now we have forms of energy. Now we have forms of energy. Luckily, the world we live in provides energy in many different forms. As we discussed, we have many forms of energy. The various forms include potential energy, kinetic energy, heat energy, chemical energy, electrical energy, and light energy. And there is another energy also. We have many forms of energy. Say potential energy, kinetic energy, heat energy, chemical energy, electric energy, and light energy. How do you know that some entity is a form of energy? Try to think by yourself. James Prescott Joule was an outstanding British physicist. He is best known for his research in electricity and thermodynamics. In your higher standard, you will learn subject called thermodynamics, and scientist James Prescott Joule contributes lots of concepts in field of thermodynamics and also electricity. In your higher standard, standard 12, we have Joule's effect, or say heating effect due to current, that is also observed and explained by Joule. Among the other things, he formulated law for the heating effect of electric current. He also verified experimentally the law of conservation of energy. There is a law of conservation of energy, we know. But who verified this experiment by experimentally? That is Joule. And discovered the value of mechanical equivalent of heat. This is very important. He derived the value of mechanical equivalent of heat, the unit of energy and work called Joule, in name after scientist Joule. So we have short introduction about Joule. You will learn his concepts and theory on thermodynamics and electricity in your higher standard. As we discussed different source of energy, and different type of energy. Now we have first is kinetic energy. We can understand kinetic energy by one activity. Take a heavy ball and drop it on the thick bed of sand. Wet bed is preferable. Drop the ball from 25 centimeter height and measure depression. Now fall the ball or release the ball from 50 centimeter height. Now release the ball from 1 meter height. Now release the ball from 1.5 meter height. In each case, measure the or measure the depression created by ball in sand. Compare the depth. By without doing any experiment, we can say that there will be larger depression when we release the ball from 1.5 meter height, and there will be less depression when we release the ball from 25 centimeter height. That is obvious. Which one them is the deepest? 1.5 meter height will be deepest. Which one is the shallowest? The shallowest depression when we release the ball from 25 centimeter height. What has caused the ball to make a deeper dent, and discuss its analysis. By this activity, we can conclude that as height of object increases, depression will be increases. So we can conclude that greater the height, greater the ability to do work. So in this lecture, we have seen what is force, what is action of force, line of action of force, when work done will be positive, when work done will be negative. After that, we seen some activity. After that, we define work done and its formula. After that, we see what is energy, definition of energy, SI unit of energy, and we conclude that SI unit of energy and work is same because energy is nothing but the capability of doing work. And till now we discussed we have many forms of energy, that is potential energy, kinetic energy, heat energy, chemical energy and electrical energy, light energy, etc. After that, we see one example or say activity in which we drop heavy ball on sand bed by different height and we measure depression created by the ball in sand. In that activity, we observe that as we increase the height, depression will increase. So we have this observation. I hope you understood all the topic we discussed in this lesson or this lecture. Further activity and topic we will discuss in our next lecture. Till then, till the time you will revise all the topic we gone through in previous lectures and practice numericals from our previous chapter, that is 8, 9 and 10. Thank you.